Okay, so I think while settling down, uh, everyone, if you don't have a TryHackMe account, please create one. But I think since you guys are here, you know that it will be a TryHackMe workshop, and I assume you all have your accounts. So you need to create one if you don't have one. And once you are done with that, let's try joining the purple teaming room, which is this link. It's Cloud Village Azure Purple Teaming. Just hope it's easy to type. I just made it too long. And of course, while doing this, let's sit back, relax, and enjoy. Okay, I'm seeing some people who are logging in. And I guess we can get started now. I'll just do some introductions first. Okay. Oh, wait. I should have given you enough time to copy paste the link. Anyone good? Not yet good with the link? Okay, maybe you can take a photo. That's a good idea. The guys with me in the back are so helpful. Thank you very much for suggesting that. Okay, it's Cloud Village Azure Purple Teaming. Also ensure that you're using the /JR since it's a join room link. Anyone not yet logged in? Anyone having problems? Please just raise your hand. I'm trying to look. Okay. Okay, I'm seeing people are good. Okay. Okay. So I think I'm seeing a lot of people who are in the room now, so let's get started. Okay, one last call. Anyone who didn't get the link, or I can proceed now. You didn't get the link. One more time. Okay. Okay. Five, four. No pressure. Three, two. All good? Awesome. Okay. So, hi everyone. Uh, First of all, welcome to the Azure Purple Teaming Workshop, care of TryHackMe, and yeah, it should have been August 2025. Total forgot that one, but yeah, let's get started. So, before we get through things, I'd like to introduce also myself. I know I was already introduced, but my name is Ari Soriano. I am from Philippines, uh, and it's my first time here at DEF CON. So please be good to me. I'm also using a Breezy as a handle. I haven't been active in CTFs before, but right now, but before I've been playing a lot of CTFs, and I'm doing some vlogs before, not so good vlogs. That's why I stopped. And right now, I've been an InfoSec guy for I think 8 years, 9 years. I don't really know right now. I'm feeling old. uh, and I'm a senior content engineer at TryHackMe. I've been working with TryHackMe for 3 years now, focusing on blue team content. So I'm not sure if you have seen some good rooms, blue team. It's on me, I guess. And most of the time nowadays, I do CTF content with them. And at the same time, I'm not doing red team with TryHackMe, but I'm also a red team a manager or someone who's leading a team of red team operators in a consulting company in my country. And without further ado, let's go to agenda. So for today, we'll just run through a couple of things in Azure. Introduction to purple teaming, some basic Azure logging, intro to KQL, and the best thing that you're gonna get to this is the emulation of an actual Azure environment. So yeah, let's get started. So for today, I'll be getting started with the purple teaming. So of course, let's run through this thing. And I think everyone here already have an idea what purple teaming is, but let's just get started. Okay, this is challenging, but yeah, let's go. Please bear with me. Okay, so As you may know, purple teaming is a practice where red and blue teams work together to test and improve detection and response. So somehow, if you guys ever doing red teaming, uh, your blue team is always active in doing things, right? When someone is doing red team, no one knows if they're coming, and blue team just anticipates that it's an actual attack. But for purple teaming, it's something that is planned all together with both of your internal teams or maybe someone that you're getting for the attack path attack part. But yeah, it's a planned simulation of different tactics, techniques, and procedures to simulate and see how your detection capabilities are. And during the activity, this is the most important part here. Both sides align their actions to enhance visibility and refine detection rules. So it's not like a fight. You're collab. Oh no, they got the wrong QR code. Yeah. So they are in the. Okay. So quick check. Anyone here with me in the Zoom? Oh no. Yeah. Okay. Yeah, I'll ask them. That really sucks. I've been talking a lot right now, and everything is being recorded, so I'll just stop talking right now. Let's test. Are we all good? Awesome. I forgot now what we're gonna do with this slide. Okay, so as I was saying a while ago, the important part here is during the activity of purple teaming, both sides align their actions, enhance visibility, and refine detection rules. So basically, when you prepare for a purple teaming activity, your blue and red team prepares everything beforehand, and everyone is aware of what's gonna happen. Oh, sorry for that. So now, just a quick run through, just to formalize things that we're discussing purple teaming. So let's say an example scenario. So this one is about detecting lateral movement activities within an internal network. So for a red team, typically they do prepare the TTPs focus on authenticating to different services, like okay, like SMB authentication, WinRM, partial remoting, RDP, and SSH. And for the blue team, of course, they prepare for their logging capabilities of internal firewall, flow logs, or authentication via Active Directory. And they prepare an initial set of detection rules focus on abnormal access patterns and authentication anomalies. So basically, as you can see, these two teams prepare beforehand and everyone knows what to expect during the activity. And of course, during the execution, both teams coordinate the timing as well. They need to know when it is executing and, of course, let the red team know if it is detected or not. So for the outcome of typical purple teaming scenario or purple teaming exercise, you need the time of execution, the executed commands by the red team, the involved assets, what assets was touched, what user accounts was used, what authentication mechanisms was done for that scenario, and of course, a detection result and preparation for round two. So if there's lack of visibility or lack of alerts triggered, you need to prepare for round two, whether you need to rerun the test cases. So now, why it matters in Azure. So anyone here in the company who uses O365, Azure, show of hands? Okay, thank you for leaking that information. Just kidding. Okay, so yeah, as you can see, as with a show of hands, most organizations nowadays operate in the cloud and often with Microsoft 365 and Entra ID tenants. And given that, I think one of the reasons is Azure offers a unified ecosystem that integrates everything that makes it easier for system sysads or cloud guys to operate things. But at the same time, more elements that are integrated all together has is it's giving the attackers some more potential attack vectors across all the services that you're using. And that's why you well, it's significant to have a purple teaming. But here are some examples of typical Azure tenants. So for some of the components, users, groups, service principals, it goes to Entra ID. All the emails, file storage, messaging go to Teams and 365. Virtual machines, networks, it's on Azure Compute. Secret Vault, so handling of secrets, API keys, and Key Vault. And more secure file storage is on blobs, which is in Azure storage. So given all that, as I was saying a while ago, every service that you use can be it can be something that can be targeted by an attacker. So in this case, here are some possible attack vectors in Azure targeting all the components that most organizations use. So for Entra IDs, they can do password spraying, account enumeration, or role escalation. For 365, you can do some phishing, token reuse, or internal data leaks if SharePoint is being targeted, or emails. For Azure Compute, of course, it's the instances, the VMs, so anyone who can access that VM. So uh, it's a fun thing to do to touch all those machines. And for the key vaults, these are the secrets that can be exfiltrated. And for the storage, of course, downloading everything that can be stored inside it. And that's why it's critical to have a purple team uh, to know whether an attack is happening in that components in Azure or in Microsoft Suite. So now, how are we going to do purple teaming Azure? So as I shared a while ago, a scenario about the internal network. So typically people do purple teaming in the internal network. They just try to run binaries, run C2s, do ransomware scenarios. So basically, most of the scenarios there are touching the components inside the internal network. It's the servers, the accounts in Active Directory. Right now, the main difference here in Azure is the most of the threat models are a little bit different because of the perimeter, which is the identity. Uh, so here, we're not considering the accounts and the rules given to the user when thinking about the possible attack vectors going to Azure. And most of the time, the interactions are not uh, just through user interfaces. You can directly communicate to the API endpoints of Azure to do anything that you want. And of course, given all these, uh, you need to understand the logging capabilities and in Azure in order to see all the possible attacks. So now let's go to Azure logging. So in Azure, there's not really a strict distinction of the events in Azure, but these are the common ones. So for the control plane events, these are the management actions that you're doing in Azure resources. So I can't really ask you guys, but if you have experience in AWS, or if you have an idea of how logging in AWS works, it has a default thing and CloudTrail that allows you to see all the actions that you do in the platform when you are logged in. So when you create a user, when you create an instance, or yeah, well, everything that you do in Azure, in AWS gets logged. So it's somehow similar to that. Everything that you do inside uh, your Azure portal, and when you touch your Azure resources, like creating a VM, creating a key vault, creating storage blobs, it all happens in the control plane. Meanwhile, the data plane events is morely focused on the data handling resources. So everything that you have, uh, every resource that's handling a data, there's a different way of logging it, and and the logging setup is more focused on that specific data. So for example, if you have a key vault and there's a secret, uh, there's uh, there's a different logging when you touch that secret. Since you are not actually doing the creation of the vault, but instead you are touching, you're accessing the vault. So that's the main difference of data plane events in Azure. And lastly, of course, I think this is the easiest one to ingest. It's the identity events. It's everything that's happening for the user or everything, every account related activity. So all the sign-ins, user group changes, or director role modifications, are or can be classified by identity events. So now I think this is one of the key things that we need to establish for this lab is the limitations in Azure visibility. Of course, actually, I really can't say that much about this one, especially uh, since it's Microsoft's setup. They don't log everything when you do get and list operations. Since as per some resources that I've seen, uh, it's really too much to ingest everything or to log everything. So as you can imagine, all the get and list operations are like when you check the users in the platform or in the Entra ID portal and you refresh. It's just like listening and listening again and again. So these operations can really overwhelm if it logs everything. Uh, and some other items. Well, yeah. Uh, but meanwhile, given that most of the logging is focused on the write, create, update, and delete on write, mostly the create ones, update, and delete actions. So I believe the reasoning for that is most of these create, update, and delete are the ones that are more significant. Since if someone like creates a user, updates something inside the platform or in Azure, it's more significant but than someone just getting something. But of course it's different if it's a sensitive data that's being accessed, which can be seen in the data plane. And now next is another limitation is that certain control plane events are too high level and lack detail. So I think it's one of the problems of blue team everywhere. If there is something that is not being logged properly, so just imagine if you have a logging in a typical sim, if you have process creation events and you don't have that command line parameter, you're just seeing a process running. You don't know what it really does until you do forensics. So somehow it looks like that, which you will see more during the lab. Next is well, yeah, logs must be explicitly enabled through the agnostic settings for many resources. So there's no option for you to just enable everything if you want. If you have a very large sum of money to spend, if you're running a cybersecurity team that has an unlimited budget, you can't do that. You need to configure one by one so that, uh, well, so that you will have the visibility that you need for that resource. Now for the logging. So for the Azure logs, most of them can be routed to one or more following destinations. So most of the time, if you're already using the Microsoft Suite, then you will be using the Sentinel as well. So it's a log analytics workspace, which can be accessed via KQL queries or, well, the built-in queries, which you will see later. Next is Azure Storage Account. This one is some uh, more raw storage. So basically, you will just store it in a storage account and just download it and access it in a raw format without having the capability to access it on time. And lastly, the Event Hub, which is something that can be used to integrate your logging to your external platform. So if you want to integrate everything in your SIM or in your in your logging platform, then you may use the Event Hub. So now we're gonna start the first part of the workshop. Yay. So now I'll be enabling the task number 2. Just give me a second. Uh, okay. So right now you guys are just seeing uh a single task, right? Okay, right? So now we'll be enabling the first part, which is connecting to the lab. So I'll just wait for it. Okay, I think you can refresh it now. Please refresh the page. Okay, so I'll be sharing my screen so that you guys can see. Oh no, it's in the dark mode. Sorry guys. I'll try to. Okay, looks better? No. too bright, right? Okay, so here, let's just complete this one. Yay. Okay, so here's the lab access. So for this lab, you're gonna be creating, well, we'll have an access to the Azure platform by clicking the cloud details. So once you've clicked the cloud details, well, actually, I already prepared the instructions, but let's do it all together. So once you have clicked the cloud details, you can just join the lab and wait for a couple of seconds. Okay, so now that I got my credentials, you can just use your credentials. So use this email and password to access the lab. And to get to the lab, you can either type portalazure.com or just click this one. So once you are here, okay, I have a different account. So let's try logging in. Okay, so once you're here, just please don't play with other things for now. You might go, well, we are just settling things down for now. Uh, okay, so once you're here in the platform, let's try. Wait, let me just show this one again. So now we are going to navigate to the Sentinel by following the steps. So go to the search bar. I don't know if I can do this. Okay, this is awesome. Let's go. Let's do this. Okay, this is perfect. So let's search for Sentinel. Click that. Okay, so now once you're here, go to this one. It's the only log analytics workspace that you can access. And after that, okay, why did I close that? Let's go here in the logs. So I hope everyone is following. So once you're here, just close this one and just click this KQL mode. So we won't be doing the built-in queries. Let's just go directly here. And okay, I want to close this one. Okay, so anyone good with the lab access, portal access? All good, all good. Okay, so now let's go to the basic intro of KQL queries. So KQL or Kusto query language is basically it's developed by Microsoft to query large amounts of structured, semi-structured, and unstructured data. And it was initially created for Azure Data Explorer, but eventually they use it for almost all their well here in Sentinel. And what you do is you can use it to query against a log repository, which is, for example, the SigninLogs or AzureActivity, where data is ingested and indexed. So a quick example, let's try this one. You have access to the portal, right? So let's try SigninLogs, then where. So basically, the syntax here right now, if you're familiar with SQL, we're just like selecting the table of sign-in logs and then doing a filter using where. So where result type, oh, okay, result type is not equal to 0. Okay, and then after that, just press enter first and then sort by time generated. Okay, so sort by is just sorting it from ascending order. And yeah, you can either click this run and Okay. Okay. So anyone following? Okay. So while before I go to some any other issues, I'll just discuss this one. So SigninLogs is a table that you want to query here. This one is the filter to show you only the failed sign-ins. Since if it's a result type is equal to 0, then it means that your authentication is successful in Azure. And here, we're just sorting the logs based on the time the log was generated. Okay, so uh, I'll just pause and let me know if you're having any problems. Okay, so if everyone is having access issues, like if you can't access Sentinel, there's a potential issue that you were too fast in logging in after the credential was provided to you, and the access control, the assignment of role is not yet established your account. So we automated that part when creating the account, so there might be some delays like a minute. And if you got in a race condition with that, then some of the permissions will not be assigned to your account. But if you were able to access the Sentinel, then that means all your permissions for this lab is all good. Okay. Okay. Uh, okay. So I think we can move now to this since we are not yet really focusing on the lab. I'll just discuss a couple of things first. So there are a couple of noteworthy KQL syntaxes that we can use. We have already used a couple of things like the where, which allows us to filter, project. This is like in SQL, when you select in a table, you're not using a wildcard, you want to use some columns. So you can use the project in order to, okay, I think it's better if we do this. Let's go. Project time generated. And for sort by, we already use that for sorting it based on time, summarize, and you want to aggregate data, and join if you want to correlate data across tables. So here you can see the project example. Okay, so now we're going to the fun part, which is emulating things. So for the lab, I'll enable again the next few parts. But before we start, I'll say a couple of things about the lab. So one, first of all, there might be a role assignment delay. Some of you may have experienced it already. It is just around a minute or two. It's a race condition when you created your account and you logged in immediately. Some of the roles might not be pushed in your account and you might need to relog in. So it may also happen in when we are using Cloud Shell later. So you can just clear the Cloud Shell session and re-authenticate if there's any problem. I'll do it later and show you guys if and next. Here's the main caveat of this workshop. Azure is not ingesting everything on real time. It takes some delay. So as you can see here, it's in UTC. What time is it now? Uh, uh, well, we are seeing now a couple of logs. Let's try to remove this one. I think it's better to see it in action. Okay, okay. So there's a lot of errors. Anyway, as I was saying, there might be some delays. So what we're gonna do is, instead of doing the lab one and check the logs, we were gonna do two or three lab activities or emulate two or three lab activities at a time, and after that, we'll review it all together. So yeah, uh, so our goal right now is to do a batch execution and wait for ingestion. So here is the first lab. So we'll do it for like 30 minutes. Let's just chill and play with the logs, do the emulation all on our own, and let's review the logs all together. So I'll enable the lab now. We'll enable the task again, uh, and we'll get started. We can refresh the room again. Okay, you should see uh, the lab one and lab two. So here, I totally forgot about this, but I have also placed a couple of questions just to make this more satisfying to complete. So I've placed a couple of questions that you can answer at the end while doing the lab. So here, what is on Microsoft domain is defcon on Microsoft.com. Not sure if you've seen it. Well, basically, it's it's the domain that you're using in the email. Okay. So now we'll be doing the well the first two scenarios. So for this one, the setup of the lab is that we're gonna do the emulation and detection by ourselves. We're not working with the blue team. You're the red team and the blue team at the same time. So okay, the first steps in the task is the emulation part. So we'll do a couple of things on our own first. Just follow the instructions here, and we'll review the logs later. Okay. So right now, I think the first part here that I want to do all together is this one. So I have created a different account aside from your account, and what we're gonna do is will log in without knowing the password. So that will simulate the failed logon attempts. So just use this user, open an incognito tab, and yeah, just try to guess a password if you can. So we're trying to emulate here the failed logon attempts and see how it looks like in the logs. And yeah, after that, just go through these instructions and uh, we'll review it all together. So I'll be leaving you guys for like 5, 10 minutes, and I'll go around and see if you need any assistance. Mm, where's the mouse? Let's go 10 minutes. Hello, Mike Des. Okay, everyone. Just for a quick announcement, we won't be just doing the first task, we will also be doing the next one. So if you're done with the first task, uh, where's the mouse? Okay. If you're done with this unusual logon events, please proceed with the next one so that we can ingest all the logs we need while we do the review later. Okay. Uh, sorry, man. Wait. Okay, hi everyone. A quick announcement. I I mistakenly deleted the actual command you need to unzip. So if you're having problems unzipping it, I just updated it right now. And where is it? Okay, wrong task. Let's go here. Here, just need to unzip it. I don't know why it was not there. Okay, just did the quick demo to check that everything is working. Looks like it. Just adjust this one. Just 24. Okay, everyone. Uh, I lost track of time, but I fixed again another typo. So for the question number 3, the question here originally is only about the user agent of the Azure related events, but I corrected it with Azure Hound. So we're looking for the Azure Hound events. How does a user agent look like in the logs? So I think let's how much time we got? Uh okay. How do you remove okay. 5 minutes. Are we all done or you guys wanna do it all together? Anyone not yet finished? Everyone is all good with the emulation? Okay, one last call. Let's do this 5 minutes. Hello, mic test. Quick announcement. Uh, since right now the platform only allows you to access, well, to view the credentials for an hour, kindly save your username and password. It will be continuously accessible in the portal, in the Azure portal or Azure platform, but yeah, you might just lose this. So so please copy paste it. If not, then you can just recreate uh well, how do I say that? You can just create a new credential once it expires. Although, yeah, I think we can be done with this lab 1 and 2, and you can just use this new credential in the next part of the workshop. So one last call. Are we all good with the activity, with the emulation? All good, all good. Okay, so I think we can now discuss. So I asked the task here is, let me just set this up. Let's close this one. Let's close this one. So the first task that we did is to emulate an activity that shows failed logon events. So we ask you to use this purple user to log in without knowing the password. So by default, what's going to happen is you guys are going to get locked out. But at the same time, it will generate a lot of failed logon attempts for us to review in the Sentinel. So now, and then after that, we use your own accounts after logging in 3 times with the wrong password. You authenticated with the correct password. So we'll also look through that. And lastly, we use this AZCLI account to relog in your credentials in the Cloud Shell. So now let's try playing with Sentinel. So, okay. So let's see what's happening. Okay, so as you can see here, we can see all the logs that has been generated. So to filter a couple of things, we can do project and try and see what are the interesting ones. So we all know that this one is just a failure, so we can just focus on the result description. But first, of course, we want the time on the left-hand side of things. Uh, then after that, what else is interesting? Your identity. And what else? The app display name is important. And IP address is good. What else do you want to see? User agent, of course. Okay, so once we run this one, we can see, well, the information that we want to see. So right now, we are just querying all the failed logon attempts. And as you can see, uh, there's really a lot, but uh, let's focus first on the purple team user. So here in Sentinel, you can just right click this one and do the filter for you. So instead of typing everything, you can just play with the table and right click it and filter it for yourself. So, or add the filter. So right now we can see that our, uh, well, here are the events of the failed logons of the purple team user. You can see most of us just use browsers. There are some Linux, Mac, and yeah, here's how it looks like when there's a failed logon or there's a mass logon uh, attempts on a single user. And on top of this, you can see how it is on what platform are we logging in. So in the app display name, you can see that the Azure portal is where we're logging in. Uh, Aside from that, some people use the Azure CLI. It was not instructed, but thank you very much for generating this one. It was a good example. And what else? What else do we see? Of course, the IP addresses. I forgot if there's a location and is there a location here? So I think this one is interesting, but I think this is just a country. Okay. So what is this? Most of them are US. What's DK? Just curious, but no, let's just ignore this one. Anyway, so basically, this is the view of your first activity. You can see that uh, while I haven't really copy pasted everything, so in order to expand this one, you can use project, you can use where to filter or what user you want to focus on. I think I'll zoom more so that you guys can see this one. Okay, so we just played with sort, project, and additional aware to filter the user that we want to check. So now as per checking, we can the key things that we can see here based on the user agent is what tool was used to do this one, and from what platform you're logging in. So you can see here in the app display name. So now let's try playing with a different one. Like let's try reviewing a single user. Uh, let's try this one first, since I did not really do anything. So let's pick the lucky person. Maybe it's just this one. I don't know who this is, but let's see what was generated. Okay, so you can see here from the start that this was done. Okay, the user did. We did not filter for failed logons. So you can see here that the user authenticated successfully. Let's put the result type. Yeah, it's zero, so it's successful. After that, well, the user did some failed logon again. And as you can see here, it was all done in the browser and logging in Azure portal. So these are the key items when you're investigating the sign-in logs. You want to check, of course, from what IP it was logged in, what is the target platform, what is the user agent, or what is the client used to authenticate. And after that, of course, the result, if it was successful login, failed logon. And yeah, after that, the user did some Azure Hound execution. Well, the user used Azure Hound to authenticate and execute eventually. So yeah, basically that is the first part of the simulation. Let me just go back to my slide. So for a quick review, here are some key takeaways. So our focus here is the sign-in log. So we just did review what we can see in the sign-in logs. How does all your activities look like? And some key takeaways. It's very significant. I mean, the result description is very significant when investigating or when reviewing the logs. It tells you what is the result, if it was a failed username, or if uh, if for any other reasons why the user is failing to authenticate. Next, the user agent and IP address or location provides a critical context when investigating. So basically, if you're in your blue team hat and investigating the logs of authentication of all your users in your tenant, you're gonna see most of the time if either they're using a VPN or not, it should be coming from the actual location that they're residing. So if everyone from your company is just from US, then everything just be logging in from US. Anything else should be different. Aside from that, the user agent tells you what is being used to authenticate. So if they're not using a browser user agent, then it must be different, something unusual. And lastly, the app display name. I've been saying this a while ago while playing with the Sentinel, but uh, the app display name tells you where the user is logging in. So as you can see, a while ago, we were logging in the Azure portal. After that, we're using the Azure CLI. And here, it authenticated to a Azure PowerShell endpoint. And yeah, that tells you a lot if this authentication attempt of or failed logon attempts is unusual or not. Especially more critical if you see a successful logon with that event. If it comes from a unusual location or anywhere else, then it should be suspicious. And as a blue teamer, what you need to do is take note of this one and implement it as a rule so that once it happens next time, you know what to do next. So now let's do this one. Let's try seeing your Microsoft Graph activity logs. So, okay, so let's play with this one first. So as you can see, there's really a lot of things. It's really a bit overwhelming. So let's try to project. I really don't want to use project immediately since I want to review the logs. Uh, I want to review everything and seeing everything. So unless you're really sure of what you want to see, don't use activity logs, the project first. So location is good. Let's play with this one. So you can see, of course, the user agent. Oh no, that's bad. Sorry. Uh, it's really hard to type looking up. Let's do it again. So quick tip, let's do this one. The request URL. Oh my God. Wait. Wait. Shift trigger. Okay. Enter where a project. Let's try location is good. What else? The request URI is good. It's a good source of information. User agent is good. Wait. And user ID is good. I mean, the hard part here is there's no actual. Okay. So from here, what we want to do is we wanted to see the enumeration activity. So I hope we see some. So here you can see that the Azure Hound activity definitely showcases the user agent usage based on the user agent. So yeah, you can see here that all these endpoints were the ones accessed. Okay, there's a lot. But anyway, the main point here is when someone is doing an enumeration on the Azure or Entra ID tenant, most of the queries are going to the graph.microsoft.com. This is the endpoint, API endpoint being hit when you are doing the enumeration. And here are the queries made by Azure Hound during during your emulation. So right now we're just showing 1,000. So let's try seeing your Azure CLI. Okay, so what we did a while ago is we enumerated users, we enumerated groups, and we enumerated service principals, which can be seen here. So as you can see, here's how it looks like when someone is enumerating your Azure tenant with the users, groups, and service principals, which are the typically basic information that's being checked. You'll see it like this. And this one, the me endpoint, this one is this one, the AZAD sign and user show. So I think most of the commands here are explicitly translatable up to this one. So you can see here the users, groups, and service principals. And of course, the main indicator here is the user agent. You can see that everything that is being executed by Azure CLI looks like this. Azure CLI is on its backend is running by Python. So yes, oh well, from Azure CLI for Linux. So you can see here that this is a complete user agent. So this one for me is one of the main indicators of someone is using Azure CLI at the same time Cloud Shell. So yeah, so let's go now here for the takeaways. So the main part here when you're looking for graph activity logs is focusing on the graph API URL. You will know here what is being enumerated. And uh, well, again, the user agent and caller IP address is very helpful in assessing whether the requests was legitimate or came from an unusual tool or location. So now let's go to this part. We'll do another emulation again. And uh, okay, I'm just setting it up. Okay, so now we can now proceed with the next part. These are just very quick. You will just access storage blobs. You will execute a command on the VM, and lastly, you will access a key vault secret. So same format, just do it first, and we'll look at the logs after. So most of these will take a little bit of effort since you need to get first the information from the first command so that you can execute the next command. So you just need to replace all these information, and after that we'll review the logs. So for yeah, same thing here. This should just be quick. So initially I scheduled 40 minutes, but I think we can do it by after 15 minutes. Okay. Just refresh your browser if you need the uh, if you don't see if you don't see the task yet. And then once you're done, if while waiting for the logs, if you just want to play with Sentinel, just go with this one. Hey guys, sorry to interrupt. I think they are done. So we can just do it more interactively all together. Okay. I think it will still be recorded. Okay. Hello. Or should I just wear this one and please just don't listen in the Zoom since my voice will be loud. Okay? I'm just doing this so that it will be recorded. So, okay. Uh I'll just wear this here. Okay, so since we're running out of time, uh, you can continue this room on your own. We're opening it until the end of DEFCON. So until maybe I'll just close this one on Monday so that you have enough time if you want. Uh, we're unsure yet if we're gonna. Well, I'll ask my boss if we can do this or publish this in public. But of course, we need to do an official announcement for this one. So for now, that's the only thing that I can guarantee you. But let's see if we can let you guys access this for one more week. I don't know. Anyway, okay, so I think if we don't have anything on the logs, I did some emulation for like the past week, so let's just check the logs. But hopefully we were able to get all the logs that we want. So for this one, all the things that you did here is all about accessing storage blobs. So the main focus here is we wanted to see who access it and is if the access attempt is successful. So let's go back to originally the uh the query is different, but I'll just do a different one since I don't have any user names. So wait, where is the request UPN? Okay, wait. Project. Okay, I'll just pick a lucky one. So this one. Let's see what this guy emulated. Okay, so it looks good. So as you can see here, almost all, well, I think all the activities were logged, starting from the list containers, list blobs, and eventually getting the contents of the blob. So you can see here that, of course, as early as this one, if you see someone enumerating the blobs or checking the containers, you should have at least a knowledge out of it before someone uh, accesses the blob. Especially most of the files that are stored here could be sensitive. And uh, wait, let me just get here. So as you can see here, the requester UPN is the username. Uh, wait, let me just. This is hard. Okay, so here the requester UPN field shows the identity used by the user. It's different from the ones that we did a while ago. So just take note of that. And next is the status code. So you can see here the status code is 200 or 206 means that your attempt was successful. So if someone is of course it indicates if someone has successfully retrieved the contents of the file. Meanwhile, if it's 404, it's a good indicator that someone is trying to enumerate blobs on your end. If you are using an anonymous logon, let's try again the anonymous. Okay, so as you can see here, the anonymous attempt that was successful was given a status code 200, and you can see here that this one was the public one. Meanwhile, if you attempt to access the other one, which is the private one, anonymously, you will see that the status code is, where is it? 404. So this one is also a good indicator that someone knows the link of your blob but doesn't have any access, which is a little bit unusual, right? So it should be a bad indicator. And of course, the user agent. Someone's using curl to enumerate or access this one. So it's bad. And of course, the IP address of the one who attempted the access. Next, the authentication type field also helps you determine if the attempt was anonymously or with with an account. So even though some people may just think that you will just monitor for anonymous access, it's still also important to monitor the unauthenticated access attempts just for insider threats. And lastly, as I mentioned a while ago, the user agent reveals the client or tool used, allowing you to determine whether the attempt to access the resource is malicious or not. Okay, for this one, for the Azure activity, let's see if we were able to get one. So not sure if you guys were able to execute the command successfully. Yes, we're able to run the command in the VM. Uh, this one, we're able to get the output. What was the result of the command? It's root, right? Okay, awesome. So for this one, what we did, it's as simple as listing the VMs and doing a command execution on the VM. So basically, this is just a scenario when you want to monitor and well catch someone who is doing an authorized command execution remotely. Uh, and yeah, this one is a little bit important since sometimes these VMs are not easily accessible. So the only thing, uh, well, not accessible in a way that you, as an attacker, you may have access to the account compromised in Azure portal, but you don't have a way to reach it. It's in a private network. So the only thing that you can do is, of course, to do this command. So with that assumption, we can, yeah, use this as a use case that we need to detect it if someone does this in an authorized way. So right now we can just see this one by searching this. I hope we got some. Nice. So now that we got this, as you can see all the information here, we can see who executed it. It's this user. Thank you very much. This is IP address, and you will know what was done or what VM was targeted. You can see here, this is the VM that was targeted. And what else are the important ones here? This one, also the VM. Uh, okay, so yeah, if you have checked the log, the problem here right now is there is no indicator of what command was executed. So if we try using this one and just search for who am I, okay, there's nothing. So there's no, by doing this in KQL, it allows you to search for all the logs existing in your tenant with a single string. So as you can see, there's nothing. So that indicates that there's no indicator that the who am I command executed was logged. So that's the problem with this use case. But still, you have an idea that someone executed a command, and the only thing left for you to do is to extend your visibility by ingesting, well, generating logs inside the VM and collecting it. And lastly, the key vault. So for the key vault, let's just do the command. Hopefully, someone was able to generate it on time. Okay. So we don't have enough. Let's try for last 7 days. Okay, so this is a lot. So now you can see here that uh okay, it's a very verbose compared to the other ones since this one is on the Azure Diagnostics table, which is running on the data plane. I mentioned a while ago, but the data plane events, they are the ones that uh monitor or track the activities made when a data is being accessed. So it makes sense since this one is a sensitive information and it should be every action there should be logged. So you can see here that from the activities that you did, You listed the key vault first. You listed the secrets out of the key vault, and of course, got the secret. So, well, yeah, you can see here that, well, this is the indicator that someone really accessed the vault and got access on the sensitive file. No, wait. The secret get is the one that indicates that it was successfully accessed. The vault get allows you, well, the vault get is, uh, it's this one, and no, it's the secret list. So this is the vault get. So when you list the vault, it gives you a vault get operation. When you list the secrets, it's secret list, and the last one is secret get. So for me, at the end of the day, this is the most sensitive one, but you still need to see at least the start. So if you just know that someone is accessing your secrets from an unusual location or from an unusual, uh, unusual user agent, then it should be something malicious. Uh, okay. So here for a quick one. So key takeaways, actions like vault get and secret list are often logged before secret get. So as I mentioned a while ago, it's an early sign that there's someone accessing the secret. The client info can also be seen. Uh, it indicates the user agent, which helps you validate if the activity was unusual or not. Especially most of the secret accesses are either integrated in a code or integrated in an SDK. So most of the time, you just know where the request should come from. So if you're seeing that someone is accessing it directly via browser or via a different way, it should be malicious and must be flagged. And lastly, when it is everything is combined with the identity, you will know if someone is really authorized to access that vault. And yeah, I think that's it for the presentation. So if you guys have any questions, yeah, we are out of time, but yeah, thank you very much for joining the workshop. And this one is for you, a gift for you. You may use this cloud code for 25 annual subscription discount. All right. Thank you very much and have a nice day.